Yesterday we talked about what makes a quadratic equation in vertex form, right? We talked about that h and k and how h and k were the vertices. I mean the vertices, the vertex. A quadratic has only one vertex. So just as a reminder, yesterday we said the vertex form of a quadratic was y equals a times x minus h squared plus k. Right? So today, what we're going to do is I'm going to give you 2 points from the quadratic. I'm going to give you the vertex and then some other points. And we're going to use those 2 points to write the equation. You ready? All right, so here in example 1, I have the vertex, -1, -2. So those are both my h and k values, right? And then I say it contains the point -2, -5. So those are one of the x and y values. Yes? So if I look at that function, y equals, hey, I've got a value for y, right? A times x, hey, I've got a value for x also, minus h, we have h squared plus, and we have a k also, right? All I have to do is plug in those 4 given values and solve for a, then I can write the equation for this parabola. So that's what we're going to do. So the first step, step 1, we're going to solve for a. We're going to solve for a. I'm going to use that equation, y equals a times x minus h squared plus k. Y'all ready? We're going to replace h, k, x, and y with those points for this parabola. So y is -5, so I'm going to replace y with -5 equals a times x is -2 minus h is -1 squared plus k is -2. So we could solve that by hand for a, or could I use insolve? Yeah. There's only one variable, right? Let's use insolve for this one. It might save us a little time, right? So remember for insolve, you do insolve in a calculator page. How do I get to insolve? What's the first thing? Menu, and then
1, 3. 3, 1.
Algebra, and then numerical solve, right? And we're going to type it in just like it looks. Just like it looks. I want everyone to practice this. Yes, ma'am. What's not coming up? All right, then we're going to type in just like it looks, -5 equals. I need everyone to pay attention to this part. This is very important. A, and you actually have to type times because your calculator is not very smart.
Yeah.
Yeah. Open parentheses, -2 minus -1 squared. Oh, squared. There we go. Plus a negative 2. Comma.
You put -1.
Oh, sorry. Negative 2 minus a negative 1. And then comma a at the end. And what do we get? Negative 3. So, using insolve, we got a equals what? Negative 3. So now I can use A, H, and K to write the equation of that quadratic in vertex form. So here H was negative 1, K was negative 2. So we're going to write that equation. You ready? Y equals negative 3 times X. Oh, we're going to do X and Y. X minus a negative 1. What's minus a negative? A positive. So plus 1 squared minus 2. We're going to do another one. I know. We found A, H, and K, right? And we plugged them in.
Why is it a positive 1?
Minus a negative is a positive. Remember, your x's lie. Your x's lie. So if it says x plus 1, then your h is a minus 1. Okay? Let's try another one. You ready? Example 2. We have a vertex located at 4, 1. And this quadratic contains the point 6, 3. Put your makeup away, please.
What does it contain?
The point 6, 3. It's right up there on the board. All right, so I'm going to use the equation y equals a times x minus h squared plus k, right? I got my vertex is at h, k, 4, 1. And one of the points contained on this parabola, x, y, is 6, 3. You ready? So we're going to replace those 4 variables with those 4 numbers. So I have 3 equals a times 6 minus 4 squared plus 1. And I want to solve for a.
0.5.
You got 0.5? Now I want us to check. I want at least one more person to give me the answer. I think we've come to a consensus of 0.5. All right, so we got 0.5, 0.5. H is 4. K is 1. So I can plug those 3 values in to my formula. Yes? You ready?
So 1.5 isn't our final answer?
No, not 1.5. Just 0.5. So we got y equals 0.5, or if you prefer fractions, like some of us do, you could put 1/2 times x minus 4 squared plus 1.
Yay.
That's it. Ooh.
Oh, never mind.
Are you okay now?
Yes.
So here in the equation, we leave x and y because remember, x and y represent all of the points that are true, right?
Yes.
And I gave you just one of the points. We just plugged that one point in. Is that okay?
Yes.
All right. So this was kind of wrapping up yesterday, writing equations in vertex form. And I want to continue that idea, and I want to take an equation from vertex form and write it in standard form. You ready? So we're going to write these equations in standard form. Standard form. Remember, standard form of a quadratic is y equals ax squared plus bx plus c. So in example 3, I give you a quadratic in vertex form, and we're going to write it in standard form.
This is different from the others, right?
What?
This is different. This one's different from the others.
Mm-hmm. So we're going to take what we did with the others and take it one more step and write it in standard form. All ready?
Hold on.
Okay. I can hold on. I can wait.
So many letters.
I know. And numbers. I know.
We have to write.
Okay. So example 3 says f of x equals 2 times x minus 3 squared plus 4. So to change my equation so that it looks like from this to this, right? From vertex form to standard form, I have to get rid of that exponent and the parentheses, right? Exactly. That's all we're going to do. So I've got f of x equals 2. What's another way of saying x minus 3 squared? What does it mean to square something? Multiply it by itself. So I'm going to have x minus 3 times x minus 3 plus 4. No, don't put it in the trash. Set it on my desk. I have to have it back, dear.
I didn't know you wanted it.
Yes, I always want them back. All right, so we got rid of the exponent. Now I have to get rid of the parentheses. What am I going to do? Multiply. I'm going to multiply x minus 3 times x minus 3. So I've got f of x equals 2 times x times x is x squared. We're multiplying. There we go. There we go. X times negative 3. Negative 3x. Negative 3 times x. It's negative 3x. Negative 3 times negative 3. Positive 9.
Wait, which one goes first?
FOIL. First, outside, inside, last. Remember? First, outside, inside, last. All right.
Wait, hold on.
So now, I see we have like terms here. We have f of x equals 2 times x squared minus 6x plus 9 plus 4. So we combined like terms are in the middle. Negative 3x minus 3x is negative 6x. All right, so we still need to get rid of that the parentheses, so I'm going to distribute 2. So f of x equals 2 times x squared is 2x squared. 2 times negative 6x?
12x.
Negative 12x, beautiful. And 2 times 9? Positive 18, right? plus 4. All right. And finally, do I have any more like terms? Yes, 18 and 4. So I have f of x equals 2x squared minus 12x plus 22. Beautiful job. Mm-hmm. All right, let's try one more like this.
Wait.
All right, example 4 says y equals 1/3 times x plus 6
Do you
squared
have to do all these
minus
steps
5.
every time? That took like 10 minutes though.
You'll get faster. Y equals 1/3 times x plus 6 squared minus 5.
I know.
All right. So the first thing I want to do to rewrite this from vertex to standard form, so we have the same directions, then I want to eliminate that squared. So when I have y equals 1/3 times x plus 6 times x plus 6 minus 5. All right. So next we're going to multiply the two binomials together. We have y equals 1/3 times x times x, x squared. X times 6,
6x.
6x, beautiful. 6 times x, 6x again. And finally, 6 times 6,
36.
36. Minus 5. All right, so next, I'm going to combine my like terms. Please stop talking. 6x plus 6x is
1/3. Oh wait, which one are you taking?
6x plus 6x is
Is 12x squared.
12x.
Wouldn't it be squared?
No, that's if you multiply. We're adding.
Put in the second 6x.
Plus 36 minus 5. All right. Next, I'm going to distribute. Jules, turn around. I'm going to distribute that 1/3. 1/3 times x squared. It's 1/3 x squared. 1/3 times 12x. It's 1/3 times 12. 4. Plus 4x. 1/3 times 36. 12. Minus 5. All right, finally, I can put 12 minus 5 together, right? So y equals 1/3 x squared plus 4x plus 7.